In today's video, we will be making hydrazine sulfate via the Hoffmann degradation. Firstly, we add 100 milliliters of 5% sodium hypochlorite solution. Once we get the sodium hypochlorite solution down to around 8 degrees Celsius, we turn on strong magnetic stirring. This is to make sure no local hotspots form when we add our sodium hydroxide. Now we add 6.4 grams of sodium hydroxide. This is to raise the pH to a level that we decrease the formations of other byproducts of this reaction. Once everything's dissolved, we can turn off our magnetic stirring. And we can cool it down to around 0 degrees Celsius. Now to create our second solution. We add around 150 milligrams of gelatin to a beaker. Then, on top of that, we add around 5 milliliters of water. This is to dissolve the gelatin. You may need to heat and stir. That's what I had to do. It wasn't filmed here, but I also created a solution of 4.4 grams of urea and 15 milliliters of water. Now we add our gelatin solution to our urea solution. We have to have strong magnetic stirring to make sure it's thoroughly mixed and some heating to keep everything dissolved. Now for the fun part. We quickly add our urea and gelatin solution to the sodium hypochlorite solution with strong magnetic stirring. This forms an isocyanate intermediate which quickly decomposes into carbon dioxide and hydrazine. This is why you see a lot of bubbling and the color change. I was very lucky here. Sometimes when making hydrazine you get a large amount of carbon dioxide formation and this can lead to an overflow. Now we have to heat up this solution just to drive forward the reaction and make sure all of the carbon dioxide gets out of solution. Since this is an equilibrium reaction, it can go both ways, and if we remove the carbon dioxide, it can't go back. It's held at 85 C for 5 minutes. We can turn off our heating. Now, we can get together our 50-50 sulfuric acid solution. We can start adding this 50-50 sulfuric acid solution dropwise. We're doing 3 things here. We're neutralizing the excess sodium hydroxide, neutralizing the sodium carbonate formed, and converting the hydrazine freebase into the sulfate salt. This must be done slow, however, because it can result in an overflow due to the amount of carbon dioxide produced. You can see the precipitate at the bottom. This is our crude hydrazine sulfate. Now for filtration. Here, we're doing a simple gravity filtration. We're just using coffee filters and a funnel I bought at the dollar store. Here's our yield, 3.3 grams of crude hydrazine sulfate. Not shown here, I recrystallized it and I got around 2.1 grams of it.